All right, guys, I'm going to get started. I hope I kind of get to show you how we're going to put all this together today. Now, listen, if you have your unit circle out or handy, that's great. The unit circle definitely has every answer we need for today right on it. It's a great tool to have. However, I try to train you guys to be able to do these problems without a unit circle, because in the future, if we're doing this or in calculus, these are certain answers that they expect you to know from memorization, basically, and they always ask you to find the exact answer, so that means you can't use your calculator. So I try to train you guys to do it if you don't have a unit circle, just because maybe you won't in the future have one handy. All right, but let's just review a couple things, then we're going to jump into the examples. All right, so remember, we have two special right triangles. We have the 30, 60, 90. If you can label these triangles from memory, you're not going to have any problem with the problems that we do today. A 30, 60, 90 has what side length? It's a 1 across from the 30, a root 3 across from the 60, and a 2 across from the 90. Now, a lot of you always seem to have that memorized from geometry, so that's great. It's a 1 to root 3 to 2. And just know smallest angle gets smallest side, biggest angle gets biggest side. All right, then we have the 45, 45, 90, which was 1 to 1 to root 2. If you can draw them, then guys, you're literally going to know the sines, cosines, tangents, cotangents, cosecants, and secants of any special angle and any multiple of it. And then if you can remember, all students take calculus, what quadrant each angle lands in will give you either a positive ratio or a negative ratio. That'll then tell you whether your ratio is positive or negative. So this is kind of how I answer all the questions instead of relying on the unit circle, all right? The only time I use the unit circle is for my quadrantals, my 4 quadrantal angles. I have 0, which is the point 1, 0, 1 to the right. So there's the cosine, sine, and then tangent of 0 radians or 0 degrees. At pi over 2, 90 degrees, that's the point 1, 0, because it's 1 up. This is the unit circle. So there's my cosine, sine, and then I can build the tangent of pi over 2. Pi radians, which is 180 degrees, falls at the point negative 1, 0. So there's my cosine, my sine, and I can build the tangent. And then I can obviously make any reciprocal trig function. All right, at 3 pi over 2 radians, which is 270 degrees, that's 1 down. So that's the point 0, negative, which is there's your cosine, there's your sine, and you can build the tangent and then any reciprocal trig function. Okay.
Are those both 1, 0?
Oh, I'm an idiot. Go ahead. I think I do that every single time. Sorry, all right? And then over here, remember, when you are on the unit circle, the cosine of any angle that is intersecting the circle is represented by the x-coordinate of that point. The sine of any angle intersecting the unit circle has a sign that is represented by the y-coordinate of that point. And then the tangent, by definition, guys, don't ever forget, is sine over cosine. So that would be the y-coordinate over the x-coordinate. All right, the secant, it's the reciprocal of cosine. So technically it's 1 over cosine, right? So it would be 1 over the x-coordinate. But I don't even do that. I literally just take the x-coordinate and flip it over. It's the reciprocal of that. I'm gonna trip on that, so I better stop. All right, cosecant is the reciprocal of sine, so that's 1 over sine theta, which would be 1 over the y-coordinate. But again, I'll just take my y-coordinate and flip it over, take the reciprocal. And then cotangent is the reciprocal of tangent, so by definition, it would be cosine over sine, which would be the x-coordinate over the y-coordinate. And again, you could also think of it as 1 over the tangent. Okay. I want to remind you guys of something. Remember, the 6 trigonometric functions are functions of an angle. You plug an angle into each one of these trig functions, right? Sine of theta. You're plugging an angle into the sine function. So an angle goes in and a ratio comes out. So all of these, if we were to graph it in the very near future, all of the x-coordinates would be angles and all of the y-coordinates would be a ratio. The only reason I like to put that is because when we get to this first problem, I'm going to ask you guys, what's the sine of 330 degrees? So I plugged an angle in what should the answer to this question be? What should come out? A ratio. Because believe it or not, when I start doing these problems, the amount of students, now it's not a lot, but it's enough. The amount of students that will tell me the answer is another angle, like what? If you plug an angle in, you should be telling me the answer is a ratio. So the answers to today's questions are all ratios. All right, let's do it. Here we go. I'm gonna put it all to some good use now. I have my unit circle handy on the next page. If I want to refer to it, it's going to be a little difficult flipping back and forth, but just so I can show you how to use it.
For a second, I thought science 330 was the problem.
Oh, that is the problem. It's going to be the problem that we do.
Oh, for one?
Uh-huh.
All right, so never mind.
Okay, here we go. So guys, I would like you to tell me what the sine of 330 degrees is. I'm going to do the first few in degrees, and then I'm going to do the rest in radians. Because if you can do it in radians, you can definitely do it in degrees. All right, so to find the sine of 330 degrees, they're going to ask you to find the exact value, the exact ratio. So in reality, you need to know, number one, where does 330 degrees land? So guys, 330 would be all the way to there, right? Because all the way around would be 360. So the way I train you guys to do this is, what's your reference angle to 330 degrees? 30 degrees, right? So in reality, what you're doing when you find the sine of 330 degrees, you are really finding the sine of a 30-degree angle, because that's the one that would have fit inside a right triangle, the reference angle, but you're in quadrant 4, all right? So guys, what's the sine of a 30 degrees? Sine 30 is, anybody have it memorized yet? 1/2. Sine 30 is 1/2. If you don't remember, go to your little triangle. 1/2, 1/2. So it's 1/2. But what coordinate is the sine function? It's a y coordinate. So would your ratio be positive or negative? All students take calculus. Only the cosine ratio is positive for angles in quadrant 4, which means the sine ratio is negative. Because guys, what would the y coordinate of a point be in quadrant 4? It would be a negative y coordinate. So it would be a negative ratio. So negative 1/2 is the answer to this question. So with the unit circle, they want you guys to, 330? That's right there. The y coordinate's negative 1/2. So yeah, the unit circle makes it 1,000 times easier. You just get the y coordinate from that angle. But what if you don't have a unit circle handy? I'd like you to be able to do these problems without it. But every single answer is somewhere on this circle. I'm telling you right now. All right, let's do another. Again, I'll do a couple in degrees, and then we'll switch to radians. What about the cosine of 240 degrees? First, let's see where it lands. Let's not look at the circle, because yes, it's the x-coordinate at 240 degrees, but let's do it ourselves. So where does 240 degrees land? Right there in quadrant 3, right? Because all the way to there would be 270. So guys, what's your reference angle? What's your reference angle from 180 to 240? It's a 60. It's going to be a 30, 60, a 45, or some multiple of it. So it's going to be, what you're really doing is you're taking the cosine of a 60-degree angle, but you're in quadrant 3. So now guys, what is the cosine of a 60-degree angle? 60 degrees cosine, 1/2. It's 1/2. So the answer is definitely 1/2. But since you're in quadrant 3, all students take, only the tangent ratio is positive for an angle in quadrant 3, which means your cosine is negative, because what would the x-coordinate be for an angle in quadrant 3? Or an x-coordinate? It would be negative. So it's negative 1/2. And again, if you have your unit circle, you'd go to, 240 degrees, the x-coordinate, it's negative 1/2. It's there, I get it, but what if you don't have it in the future? All right, let's do this one. What about the secant of negative 225 degrees. Where does negative 225 degrees land? Well, here's negative 180. That's negative 270, so it must be somewhere in there. So what's your reference angle in between negative 180 and negative 225? It's positive 45 degrees. You are taking the secant of 45 degrees, but you're in quadrant 2. So the secant is the reciprocal of cosine. So if you go to your 45, 45, 90, just go to one of them. Your cosine would be 1 over root 2. So your secant is root 2 over 1. It's the reciprocal. So it's root 2. But you're in quadrant 2. So all students, only the sine or cosecant ratio would be positive, which means the secant is negative, because the cosine would be an x-coordinate. The x-coordinate is negative in quadrant 2, so would his reciprocal, and you're done. So again, in this case, you'd go to the circle, you'd go to the angle that lands, I guess it would be 135 on your circle because it lands in the same spot as negative 225. Take the x-coordinate, flip it over. So it would be like negative root 2 over 2 that you would reciprocate. All right, let's go to radians now. Are you guys okay? Everybody good? Do you remember doing this last year? No? Not at all? Okay. All right. Here we go.
I don't think we even talked about like secant of secant.
Okay.
That we tangents and out. I mean, I don't know if that was just because of COVID, but yeah.
Yep, it might be.
Last year was a blur.
It's a blur. That's it. Me too. I feel that way. All right, we're going to do it in radians now. So now you kind of got to get good. I tried to show you those anchors so you could figure out where things land. What if they asked you for the cosine of 7 pi over 6? At the end of the day, that's 7 30-degree angles, right? 180 divided by 6 is 30. It's 7 30-degree angles. Or if you remember, in the worlds of pi over 6, to make pi, you would need 6 of them. So every 6 pi over 6 gets you half a rotation. 6 pi over 6, 12 pi over 6, 18 pi over 6, 24 pi over 6, and you can just keep counting it. So 7 of them, here's 6. The 7th one would be in the next quadrant. So there's 7 pi over 6. What's the reference angle in between 7 pi over 6 and 6 pi over 6? It's 1 pi over 6. Your reference angle, remember, it's always a positive angle between 0 and 90, so it's either going to be 30, 60, or 45. They're not going to give you an angle who has a reference angle of 28 degrees. That's not one of our special angles that we can memorize the side lengths of. All right, so this is really the cosine of a pi over 6. Or guys, if you want to put 30 because you can work in degrees better, you do what you got to do. You're taking the cosine of a 30-degree angle, but you're in quadrant 3. So what is the cosine of a 30? There's 30 cosine root 3 over 2. But you're in quadrant 4, so what is the sign of this ratio? All students take, only the tangent ratio should be positive, which means cosine is negative. Because what would the x-coordinate be for a point in quadrant 3? The x-coordinate would be negative. All right, and again, that answer is right on your unit circle with that x-coordinate at that point. All right, how about you guys try this one? Find me the tangent of 5 pi over 3. It's getting a little crowded, I'm sorry. Tangent 5 pi over 3. Find out what where the angle lands, find your reference angle, and go. Remember, in the world of pi over 3s, every 3 pi's over 3 make pi. So you can count it around that way. Right, the 5th one should be in quadrant 4. Because guys, at the end of the day, it's 5 60-degree angles. Pi over 3 is 60. 5 60-degree angles, where does it put you?
I think it's like 300 degrees in this case.
Yeah, it is. So you'd definitely be in quadrant 4, between 270 and 360.
I looked at the chart for the actual number.
Okay. All right, so you're taking the tangent of a pi over 3 is a 60. So 60 tangent would be root 3 over 1, that's root 3. But you're in quadrant 4. All students take calculus. Only the cosine ratio is positive for angles in quadrant 4, which means the tangent ratio would be negative because it's a y-coordinate over an x-coordinate, right? The y-coordinate is negative, but the x-coordinate is positive. So that's going to create a negative ratio, and you're done. Did you guys get it? You're good? Nice and easy? Excellent. And we shouldn't need the circle. The goal is to not need the circle. I know it's kind of like, well, didn't you just spend all this time teaching us the circle? Yes, yes. I want you to know what it means and what it represents. But you don't always have a unit circle, hanging out in your back pocket. So you want to make sure we can do this without it. How about the sine of negative 11 pi's over 4? Let's figure out where this is, guys. So we're at a negative angle. We got to rotate clockwise now. So just remember, in the world of pi's over 4, every 4 of them make a pi, make a half a rotation. So if I'm going to the negatives, I'm going this way. That's negative 4 pi's over 4. That's negative pi. So every 4. So then this would be negative 8 pi's over 4. If I go another 4, this would be negative 12 of them. So where's the negative 11? Right here in this quadrant. So you had to make one full rotation, and then you had to keep rotating to there, because that would be your negative 12 pi over 4. So there's your negative 11, which means what's your reference angle? 1 pi over 4. So what you're really doing is taking the sine of a pi over 4, but you're in quadrant 3. So guys, what's the sine of a pi over 4? What's the sine of a 45-degree angle? 45, the sine is 1 over root 2. You rationalize that, it's root 2 over 2. So again, it's 1 over root 2, but that becomes root 2 over 2 once you rationalize it. And now, according to all students take, only the tangent ratio is positive, which means the sine ratio would be negative because it's a y-coordinate. And what's a y-coordinate of a point in quadrant 3? It's negative. All right, so again, these problems, these questions, they pop up inside of other questions, and they expect you to know the answer to this. They want you to know this ratio cold without using a calculator. What is the exact value of the tangent of 5 pi over 3 radians? All right, so I'm just having you guys practice a ton. How about you guys, I'm going to erase this. It's just getting a little too crowded for my eyes. How about you guys try, I want the cotangent of 7 pi's over 4. Figure out where it lands, get your reference angle, get your ratio, get your positive or negative sign. Remember, in the world of pi over 4, every 4 of them make pi, a half a rotation. So there's your 7th hanging out there.
That's quadrant 4.
That's quadrant 4. So what you're really doing is taking the cotangent of a pi over 4, but you're hanging out in quadrant 4. So sometimes I'll do this as a tangent. What's the tangent of 45? Because I have those ones memorized a lot. And then I'll just flip it over. But if you have your triangle, you don't have to flip anything over. Cotangent pi over 4, instead of O over A, it's A over O, but it's 1 over 1, guys. So the tangent or cotangent of a 45 is 1. All students take calculus, only the cosine ratio is positive. So that means the cotangent, which is the reciprocal to tangent, must be negative. All right. How about the cosecant of, what did I say? 3 pi over 2. That's 3 90-degree angles. Where does 3 90-degree angles put you? Right on that negative y-axis. It's a quadrantal. So this is the only type of question I actually use the circle on. Go get that ordered pair right on the y-axis on the unit circle at 3 pi over 2 radians, or 270 degrees. All right, so what point was that? You're 1 down. So the cosecant is the reciprocal of the sine function. So first I would take, what's the sine of this angle? The sine is -1. Flip that over, the reciprocal is -1. And you're done. So again, those are the ones that I definitely use the circle for if I'm on an axis, one of my quadrantals. Because it's always a point with a 0, a 1, or a -1. All right, what about the cosine of 5 pi's? Where are 5 pi's? So guys, remember, every half of a rotation is 1 pi. So that's 1 pi, 2 pi, 3 pi, 4 pi. Woo! There's your 5th pi right there. What point is that on the unit circle, 1 to the left? They want the cosine. The cosine is always the x-coordinate. Done. Okay? All right. Guys, I could sit here. I literally have like 30 problems written down. I could just keep going. Let me see what else I have. What's up?
There are 6 more spaces.
I know. I'm probably not going to fit them all in. They'll be on my filled-in notes because I just tried to think like, oh, what about this one? I feel like your book, the homework, they like to give you ones that rotate around a lot. So you kind of got to be good at counting. That's 19 30-degree angles. So you could count 19 30-degree angles, or remember, in the world of pi over 6s, every 6 of them make pi, a half a rotation. So this would be 6. This would be 12. I'm trying to get to 19. 6 more, that would be 18 pi's over 6. So where's the 19th pi over 6? In quadrant 3. You just count all by 6s. All right, so then what's the reference angle? If this is 18 and that's 19, 1 pi over 6. So what you're really doing is taking the tangent of pi over 6, but you're in quadrant 3. What is the tangent of a 30? Tangent 30 is 1 over root 3, but you would rationalize that, and it's root 3 over 3, right? The tangent of a 30, lots of 3's. So root 3 over 3, all students take, the tangent ratio is the one that's positive for angles in quadrant 3. So the ratio would be positive, because it's a negative y coordinate over a negative x coordinate. Okay, I'm gonna have to stop. I want to go down and show you examples A and B. So what they do now is they just start putting them inside of like multiple problems. All right, so they want you to find the value of this expression, but they want the exact value. So first we have to take the sine of pi over 4. Guys, what's the sine of pi over 4? What ratio is that? What's the sine of a 45-degree angle? 1 over root 2, but rationalize it. It's root 2 over 2. And you're in quadrant 1 with pi over 4, so it's always positive. Then you're going to times that with the cosine of pi. What's the cosine of pi radians? Well, there's pi right there. What is the x-coordinate? Because it's cosine. It would be, anybody know? -1, yeah. And then we're going to subtract. I want the sine of 3 pi over 2. What's the sine at your third 90-degree angle? Well, guys, your third 90 is right there. That's 3 pi over 2. That's the point, what, 0, -1? They want the sine. The sine is the y-coordinate. So what's the answer to that? -1. And now you just evaluate this expression. First, we would multiply. Root 2 over 2 times -1 is negative root 2 over 1. Then we're going to subtract -1, which is plus 1. So now it's got to get a common denominator and add them together. My common denominator would be 2. All right, I would times top and bottom by 2. And now on top, negative root 2 plus 2, guys, you can't actually add them. They're just negative root 2 plus 2.
-2 minus root 2.
Yes, you can. I don't think the order would matter at all. And it's all over 2. And nothing reduces, and you're done. So again, there's going to be some of these on your homework where they're mixed into an expression. You got to get your ratios and then do PEMDAS, basically. All right, look at this one. The secant of pi over 4 squared plus the cosecant of pi over 2. We got to get the exact ratios and then PEMDAS. All right, so first, who's the secant of pi over 4? So guys, pi over 4 is 45. Secant is the reciprocal of cosine. Cosine would have been 1 over root 2, so secant is root 2 over 1. So it's root 2. So that's root 2 squared plus the cosecant of pi over 2. Well, pi over 2 is up here. It's your first 90-degree angle, and it's 1 up. Cosecant is the reciprocal of sine. So what's the sine at pi over 2? 1, the y-coordinate. Flip it over. What's the cosecant? 1. So what's root 2 squared? 2 plus 1. The answer is 3. So the expressions themselves are fairly easy. Just got to get those ratios to be plugged in is probably the harder part. And that's it. Guys, if they ask you any trig function of any special angle or multiple, any 30, 60, 45, quadrantal, any multiple of that, they expect you to be able to find that ratio from scratch exactly. Don't ask your calculator. It'll give you the decimal version, which you have to round because these are all irrational numbers. You should be able to get the exact ratio. All right? Is everybody okay? Awesome. All right, so I did create a homework tonight. It's long, but you can see how quick the questions are. So it's not like you're spending 10 minutes on each question. It's pretty quick. There's about 34 of them. And then you guys, that homework is not due until Sunday night. And I am giving you tomorrow in class to do that homework. You do not have to log on to a Google Meet. You can just work on your homework. I'll jump on the Meet just in case anybody is struggling and wants extra help. But you do not have to come to the Meet. Work on this homework. It is due Sunday night, okay? All right, let me take the attendance, and then you guys are going to be good to go. Everybody's good here? Yep.